Example 2. Gerald has invested a $15,000 inheritance into an account that earns 12.3% compounded quarterly. The interest rate is fixed for 10 years. Gerald plans to use the money for a down payment on a house in 5 to 10 years. Question A, what is the future value of the investment after 5 years or 10 years? That's tricky because that means that we have to do that twice, 2 in 1 question. B, how much interest did he earn after 5 years or 10 years? And C, if the investment had earned simple interest, would the amount of interest be the same? Why or why not? And hint here, we're going to compare the interest rates, the interest earned after 5 years. So let's write down some of the important bits. We don't know what the future value is, but we do know that the principal is $15,000. We do know that the annual interest rate is 12.3%. So that means when we're looking at our I, we know that our denominator has to be 4 because it is compounded quarterly. But we want to turn that 12.3% into a decimal, so it would be 0.123. The number of compounding periods, well, that's different based on how many years. So let's do this for 5. So 5 years times the number of compounding periods per year, which would be 4. So let's solve A. For 5 years, we're going to say A equals P times 1 plus I to the N. But luckily we have all of our work on the side here, so we just substitute. So 15,000 times 1 plus I, which is 0.123 all over 4 to the power of, not n, but 20. What I'm going to do is I'm going to simplify what's in this bracket first. And now it's just a simple plugging into it into our calculator. So when I say 15,000 times 1.03075 raised to the power of 20, we get 27,488.95. So let's remind ourselves what this means. So it means that after 5 years, he invests $15,000, and after 5 years, the future value, the total amount that he'll have in that investment is $27,488.95. What about for 10 years? Let's see what changes. We still don't know what A is. The principal is still the same. It's still 15,000. The interest rate per compounding period, it's just the same. It's 0.123 all over 4. It's still compounded quarterly. The only thing that changes is the number of compounding periods, which, you know what, that makes sense, because instead of going for 5 years, we're going for 10. So we have 10 times 4 compounding periods per year, which comes to a total of 40. So instead of raised to the power of 20, we're going to be raised to the power of 40. So let's rewrite our formula. A equals P 1 plus I to the N. We know that our principal is 15,000. 1 plus I, which is 0.123 all over 4 to the power of N, which in this case is going to be 40. Just going to simplify what's in the brackets. $1.0375 to the power of 40, though this time, for a full amount of $50,376.15. Woo! So if we keep it in for twice as long, we're going to get way more money out of it. So let's look at B part. How much interest did he earn after 5 years or 10 years? So remember that interest is just the future value minus the principal. That's it. Okay? You take the amount that he ends up with and you subtract what he initially invested and you'll get what the interest is. So if we were to do that, we're going to say $27,488.95 minus the principal, which is $15,000. So after 5 years, compounding quarterly at 12.3%, we'll have $12,488.95 and 95 cents worth of interest. Let me just rewrite that. So this is how much he's earned in interest. But what happens after 10 years? Interest is future value minus principal. So our future value in the case of 10 years is $50,376.15 minus the principal, $15,000. So we are left with $35,376.15. So it's a significant amount of difference. If you think about it, it's more than double the amount of interest in double the amount of years. Now let's compare this actually with the interest that he would have earned in simple interest. And we're just going to compare it with a 5-year point. So if this were to be simple interest, the compounding periods wouldn't really matter. We're going to say interest equals principal times the interest rate times t. In this case, we know that our principal is $15,000. We know that our interest rate is 12.3%, so 0.123. And our time, we're just going to compare the 5-year point. Okay, so we're going to substitute that into our formula. 15,000 times 0.123 times 5 years. So before we put this into the calculator, what do you think? Do you think that compounding compound interest gives you more interest or simple interest? Well, if we would have used a simple interest investment, we would have only received $9,225 worth of interest. Now let's compare these two. Look at that. We get significantly more interest if we use compound interest instead of simple interest. And if you think about it, it makes a lot of sense. Because at the end of that compounding period, all the interest that is made is reinvested along with the original principal to get interest on interest. So it will grow as an investment faster than a simple interest would, investment would, because you're just getting the same amount of interest every single year. Whereas in a compound interest formula, you're actually getting more and more interest as time goes on.